Again, we have a problem where it gives us a sequence and it asks us to write a rule or an equation to find some unknown term m, which in this case is 13. Okay, so remember the first step is to identify what type of sequence it is. Here, to go from 1 to 3 and 3 to 9 and 9 to 27, we are actually multiplying by 3. So that means that this is a geometric sequence. So let's fill in what we're missing here. So to know what A5 is, I'm going to multiply 27 by 3, which gives me 81. Multiply that by 3, we get 243. Multiply that by 3, we get 729. Now remember that geometric sequences start out slow and increase very rapidly. Notice we started at 1, we're on the 7th term, we're already at the number 729. So this follows kind of a pattern of an exponential function. If you'll recall, exponential functions have the equation y equals a, which is our initial value, b, which is our common ratio, raised to the power of x. So we want to go ahead and put this in terms of a sequence using the variables that we're going to be seeing with a geometric sequence. So a is your initial value or your first term. So let's write that as a1, just to be clear. B is the number that we're multiplying by each time, which we now know is our common ratio, so we're going to use the variable r. X, when we think of it in terms of an exponential function, refers to how many years or how much time this pattern is continuing. But in this case, my exponent is going to refer to how many times I'm multiplying my common ratio, which in this case is 3. Now, if you'll remember back to the arithmetic sequence video, the amount of times that we actually apply that common difference or that common ratio is one less than the term we're looking for, or our unknown term, n. So we're going to say raised to the power of n minus 1. Now let's plug in the information that we have. Our first term in this case is just 1, so that's easy. Our common ratio is 3, and I'm looking for the 13th term, so don't forget I'm going to say 13 minus 1. 13 minus 1 is 12. So what this right here is telling me is that I'm going to multiply 3 12 times to get the 13th term. 3 raised to the 12th power is going to give us a nice big number, which is 531,441. Now we multiply that by our initial value, which in this case is 1. So our final answer is 531,441. That gives us our 13th term.